Listen to a conversation between a student and a professor.
So, the reason I came in, Professor Williams, well, it's about what you were explaining in your philosophy class today.
Yes?
Yeah, the whole thing about simulations. Would you mind going over that with me again?
No problem. The main point of the book I was referring to is that, well, in a postmodern world, we live in a world of unreal images, of simulations. For example, the things we see on TV become a reality for us, even though they're not, in fact, real. They're representations, simulations of reality.
Postmodern world?
Right. It came after the modern one.
Gee, thanks a lot.
No, sorry, you're right. Postmodern, well, that's a sticky term that covers a lot of things. Let's save that for later. But back to my point about simulation. It leads to hyperrealism, a feeling that something is more real than real.
Whoa. I'm sorry, but all this is... I just don't get it.
Video games, virtual reality, theme parks, all of these remove us from reality. Worse yet, we can begin to think these simulations, these fake experiences, are real. Or we don't know the difference anymore.
Well, actually, I'm starting to think this class is not for me. In fact, I wonder if I might not do better just to drop the course.
Oh, you're still having trouble following this?
Yeah, I just don't think I'm cut out for philosophy. I signed up because my academic advisor, well, I feel like my advisor sort of pushed me into it.
I see. If I may ask, what are you interested in?
I want to be a lawyer.
Well, then, you need a firm base in logic and argumentation. So this philosophy course is basically a necessity for you.
I hope not. I could only get maybe half the lecture.
That's pretty good, then. I covered a lot. Probably too much. And these were only some opening remarks for the first day of class. I was just skimming through some contemporary ideas in, well, more cultural theory than actual philosophy. So you needn't worry. Starting next week, we're going to read some real philosophy. Primary sources like Plato, Rousseau, Emerson, and you'll be able to talk about them in small discussion groups led by graduate assistants.
Well, I don't know.
I understand you're uneasy about this course, but, well, give it another chance. Attend a few more sessions, get into your assigned discussion group, then see how you feel. Look, these ideas, like what postmodernism really is, they're ideas that people develop over years, careers, lifetimes. I didn't mean to scare you.
Well, I guess I should have just taken it in the spirit it was intended, as an intro. Well, you're right that instead of trying to wrap my mind around every little detail all at once, I need to work on seeing the bigger picture and not getting so stressed out.
Well, don't think you're going to learn all of law right away either. Have you looked at the law library lately?
Yeah, talk about scary.
What is the conversation mainly about? How does the student feel about the professor's explanation of simulations? Who influenced the student to sign up for the philosophy course? What does the professor imply that she should have done differently in the first class? What does the professor imply will make the student feel more comfortable with the course in the future? Listen to part of a lecture in an architectural history class.
Now, we've talked about how social concerns informed the designs of some architects in the United States in the 19th century, and it holds true not only for building architects, but also for landscape architects. The way we design our landscapes, it's hugely important too for how we live, easily as important as the buildings we live in. And these social concerns were especially apparent in the work of a huge figure in the history of landscape architecture, Frederick Law Olmsted. Olmsted is particularly associated with the building of public parks in the mid-1800s. At that time, with industrialization, the United States was moving from a rural, agricultural way of life to an urban one. Many people were moving from farms to cities, and cities themselves were growing fast. And that was creating concern and anxiety about people losing touch with nature. Now, based on your reading, how did this situation relate to Olmsted? Ken?
Well, he saw that as cities grew to accommodate the larger populations, a lot of open space would be used up for buildings and infrastructure. I guess he thought that eventually there might not be any open space left, green space.
And others shared this concern as well, people with some power.
Right. So in New York City, they decided to build this huge park, Central Park, and they hired him to design it.
Right. Olmsted together with Calvert Vaux. And what Olmsted wanted to do through this park and others was to preserve people's connections with the natural world. Central Park is his best-known project, and it really launched his career. There were so many details that made this such a model of success that, Julia.
It seems like he integrated the park into the city really well, especially by putting streets across the park so that you could still get from one side of the city to the other.
And those streets don't disrupt the unity of the park very much, but why not? What feature, what modification did he make?
Well, they weren't any narrower than regular city streets.
No, not narrower.
Oh, lower. He put them at a lower level than the rest of the park and used short tunnels.
Yes, exactly. The streets were designed to be as unobtrusive as possible, not interrupting the flow of people walking in the park, not interfering with the natural setting, while still functioning as streets. Making tunnels was the best way to achieve this balance in many locations within the park. And then paths for pedestrians went above the street throughout the park. What's so special about it to me is Olmsted did such a good job of using the space by emphasizing the natural elements of the park. So, with ground areas that were low, he made them even lower and turned them into ponds and meadows. Then he emphasized some high, rocky areas. He planted small forests close to grassy meadows. By doing this, he emphasized contrast in contour and texture, but he made it all work as a whole. He also made the northern half of the park more of a nature preserve, while the southern part was more for people and recreation. So Central Park was a huge success, and it led to more work for him. He designed dozens of urban parks throughout the country, so that's probably his greatest legacy to architecture as a profession, but not his only legacy. He also designed landscapes for public buildings, campuses, even entire towns. In that area, urban planning, he showed the same concern for preserving open spaces that he'd shown with Central Park. For example, his design of the town of Riverside, Illinois. He planned it so it would have the conveniences of city living, but it also had open space for recreation, for nature. He lowered the streets slightly so they wouldn't block natural views, like views of the Des Plaines River, which flows through Riverside. He really wanted to preserve the shores of the river, so he didn't put houses there. Instead, he turned the riverfront area into a park. And about a quarter of Riverside is parks. What's also remarkable is that Riverside, well, even today, the streets and other parts of Olmsted's plans are almost completely intact. It's really an oasis in the city that's grown around it, the city of Chicago since that time. Goes to show you how valuable good design really is.
What is the lecture mainly about? What does the professor imply about the increase in the population of urban areas in the middle of the 19th century? What is one of the features of Olmsted's design of Central Park that the professor particularly admires? What design feature did Olmsted incorporate into both Central Park and the town of Riverside, Illinois? What does the professor say about the town of Riverside, Illinois today? Listen again to part of the lecture, then answer the question.
And those streets don't disrupt the unity of the park very much, but why not? What feature, what modification did he make?
Well, they weren't any narrower than regular city streets.
No, not narrower.
What can be inferred about the woman when she says this?
Well, they weren't any narrower than regular city streets.
Listen to a conversation between a student and a university employee.
Hi, I had a question. I normally park my car in the lot next to the music building.
Oh, okay. Lot 7.
Yeah. I've never had a problem using that lot before.
Is this about us closing the lot this Friday? We've had students complaining, but I can give you a pass to Lot 10. You know about the orchestra festival in the music building that day, right?
Yeah, right. I knew about that. My question's actually about, while I'm here, I guess I will need a pass, but the fact is I'm in the orchestra festival myself. I play the cello, so maybe...
Sorry. On Friday, that lot's for non-university guests, so you'll have to...
Go to lot 10. You sure? I am in the orchestra.
Sorry.
Okay, that's fine. I guess I'll need a pass. But anyway, I got a parking ticket yesterday.
Okay. Do you want to pay your fine now? You have 2 weeks to pay it.
Well, I don't. Actually, I don't understand why I got it. I always park in the same lot. I mean, I didn't do anything different.
Okay. Is there a code number on the ticket? I can look it up.
Yeah, I remember it. It says 036.
All right, let me check. This was yesterday.
Yeah, early afternoon it would have been.
Okay. Violation 036. It says here parking in more than one space. Do you have a big car or something? I know we repainted the lines closer together so we could fit more cars in the lot.
No, it's a small car.
Well, you must have parked over the line. More than one parking spot.
Really? I'm sure I wasn't.
We have forms to contest a ticket. Do you want one? If you don't think you did anything wrong, you can fill it out here. Let me get you one.
Oh, even though it'll probably be a great waste of time.
Okay. And you wanted that pass to lot 10, right?
Oh, right, yeah, I forgot about that.
What are the speakers mainly discussing? Why does the student mention that he plays in the orchestra? According to the ticket, what was the student's parking violation? What will the woman give the student? Listen again to part of the conversation, then answer the question.
I know we repainted the lines closer together so we could fit more cars in the lot.
No, it's a small car.
Why does the student say this?
No, it's a small car.
Listen to part of a lecture in an astronomy class.
So, we pretty much know how the biggest stars die. When a massive star reaches the end of its existence, it explodes, sending out a huge blast of energy, which then fades to invisibility within a few weeks or months. When a giant star explodes like this, it's called a supernova. To the naked eye, a supernova appears to be a bright new star, but it's not a new star. It's a dying star. However, the shock waves from a supernova excite nearby clouds of hydrogen gas, causing them to compress, which does form new stars, and that process emits a distinctive type of radiation. Now, of particular interest to us today is that this same type of radiation has been observed in places where galaxies have collided. And in those same areas, we've also observed a high rate of new star formation. So, not surprisingly, we've had a theory that colliding galaxies caused the new star formation. But there was no direct evidence. That is, until recently, when some European astronomers found clouds of excited hydrogen gas that could only have been caused by shock waves from a pair of colliding galaxies. You know, we used to think of galaxies as isolated systems, like islands in the sea of space. Now we know that they're always moving, usually in clusters. I mean, think about all the gravitational forces involved. We're talking about huge systems of stars and gas and dust. And since the average separation between galaxies is only about 20 times their diameter, it isn't surprising that they often meet. We call it an encounter. And they meet in a variety of ways. Mergers, for example, they're the most extreme kinds of galaxy encounters. A merger is when two galaxies meet and they don't have enough momentum to keep going on their separate ways, so they merge, becoming one galaxy. Usually a larger galaxy will absorb, sort of swallow a smaller one. This can trigger huge areas of star formation as enormous clouds of gas from the two galaxies collide and collapse into very active star-forming regions. Collisions are less violent than mergers. That is, they create fewer or relatively less active areas of star formation. The galaxies pass through each other, each going its separate way after they collide. The collision sends out a ripple of energy into space, plowing gas and dust in front of it. Your textbook has a great picture of a galaxy collision taken by the Hubble Space Telescope. See the cartwheel galaxy on the left? It looks like the ripples in a pond after a stone's been tossed in. That's because one of the small galaxies on the right's passed through it. And that bright ring around it, that's where colliding and compressing gas is forming stars. But which galaxy collided with it? The one on the upper right's been stripped of gas and dust, which is one clear sign that there's been a collision. But the one on the bottom's showing a lot of new star formation, which is also evidence of a collision. So we're just not sure. Finally, we have interactions. In this type of encounter, the galaxies exchange gas and dust, but don't actually collide. Many astronomers believe that the trail of gas and dust that stretches from our Milky Way galaxy to one nearby is the result of an interaction, when the gravitational forces of the Milky Way pull some dust and gas off of the other galaxy.
What about stars? Do they ever collide?
Actually, almost never. Stars are very small compared to the size of a galaxy, and they're pretty far apart from each other. Small stars. Well, that term's relative, isn't it? It's hard to imagine the massive distances we're talking about here. Even encounter seems like an odd term, as these events take a long time. We're talking billions of years, which is why most of what we theorize about comes from computer simulations. Otherwise, all we'd see is a sort of freeze frame of whatever stage the encounter is in, a single picture out of a long sequence of events. But I mentioned some new evidence. That's come from a pair of galaxies called the antennae. The antennae are at an early stage of encounter, what'll probably be a merger, and excited hydrogen gas has been found in the regions where the two galaxies overlap. We know because that distinctive radiation signature is present. And we know that there aren't enough supernovae to explain the radiation. The only other possibility is that we're seeing the result of shock waves produced by the collision of these two galaxies.
What is the main purpose of the lecture? What do colliding galaxies and a supernova have in common? How does the professor organize types of encounters between galaxies? Why are astronomers uncertain as to which of two unnamed galaxies collided with the Cartwheel Galaxy? Why do astronomers believe that the Milky Way galaxy is interacting with another nearby galaxy? What is the professor's opinion of recent observations of the antennae galaxies? Listen to part of a lecture in an ecology class.
Termites, insect order Isoptera. Hard to think of them as more than just pests that want to eat your house, but I think you'll be surprised at how interesting they are and how important they are to the ecosystem. Now, what do you already know about them?
They eat wood, lots of it.
Right. To be more specific, they eat dead wood, like dead trees in forests and plant litter. Their consumption of wood is you can think of this like recycling. Termites are recycling that litter back into soil. Their major source of nutrition comes from cellulose, the main chemical ingredient of wood and the cell walls of other plants, leaves, grasses, etc. Now, cellulose is a complex sugar, and most termites can't actually digest it. Because they don't have the right enzyme to metabolize it, to release its nutritional benefit. Now, that would be a problem, but they have a special relationship with protozoa and bacteria that actually live in their digestive systems.
Inside?
Yes, it's these microscopic organisms that break down the cellulose for the termites. They'd starve without them. And a good example of...
Symbiosis. Two different kinds of organisms live together, so it's good for one or both of them.
Good. And what else is interesting? Well, termites are social. They live in colonies like ants or bees. Now, about the colonies. Each termite colony is founded by a male and female pair that mate and produce more termites. The termites in the colony come in several types, called castes. There's the reproductive pair, the workers that gather food to feed the colony, and soldiers that defend the colony against predators, like ants. And they communicate by...
Dancing? Like the dances bees do?
Well, you're not too far off. Every colony has its own distinct smell, a scent that other termites within their colony recognize. If a worker finds a new food source, it secretes a trail of scent that others can follow to locate the food. And scent plays an important role in helping soldiers defend the colony against predators. If they detect an unfamiliar scent, well, let's say an ant is lurking around, well, the ant has a distinct smell. As soon as soldiers detect this ant's scent, it's a warning. They shift into an aggressive mode, ready to start defending their colony. Termites also communicate alarm through sound. If workers or soldiers want to sound the alarm, they'll bang their heads against the tunnels in their nest. Other termites perceive the vibrations through special sensory organs on their legs and come running to defend their colony. So they're pretty complex animals. I hope you're getting a sense of that. Eventually, a colony swarms... Oh, sorry, got ahead of myself. Only termites that can reproduce have wings, and that's only so they can fly to a new location, find a mate, and establish a new colony. So eventually, these special winged termites fly off in enormous numbers to form new colonies. They break off their wings after they land. In fact, that's how I knew I had an infestation in my house a few years ago. Pretty amazing sight. Nothing I ever wanted to see in my house. There were so many wings on the floor and windowsills. Ew. I called an exterminator, of course, to get rid of them, but I kind of had mixed feelings about it.
You're kidding.
It's true. See, the problem with destroying termite colonies is that they're really so crucial. Remember I said they recycle plant litter? In addition to creating new soil, termites themselves are a major source of food for other organisms, such as salamanders, frogs, lizards, and birds, which are preyed upon by other organisms. They're part of an ecological cycle. So it has an impact if too many termites are removed from the ecosystem.
Sorry, Professor, but I'd be more concerned about them eating my house.
As I was. Which reminds me of an article I wanted to tell you about. Someone recently coined a term, decompiculture, and let me write that down. Decompiculture is the idea that humans should cultivate organisms that can decompose our waste. The professor suggests in his article that we intentionally raise them. Humans create a lot of waste that often gets dumped into landfills or water sources. It's really just pollution. Well, this waste can be fed to termites. Waste like...
From sawmills or paper mills? So, termites could help us. Huh.
Yes. When you think about it, it's actually another kind of symbiotic relationship that humans would cultivate with termites.
What is the lecture mainly about? What are two occasions when the professor mentions symbiosis? What does the professor say about termite communication? Why did the professor find termite wings in her house? What statement best characterizes the professor's attitude toward ridding her house of termites? According to the professor, what could decompiculture be used for?